Okay, hello everyone. As part of the demonstration that I'll be doing, I've set up a preliminary test station, and I'll be testing 3 different power supplies. There's this conventional transformer, which has 170 volts open circuit DC. This is a homemade transformer, which has 260 volts DC open circuit, and then there's the DC generator over here, the little generator that develops about 123 volts open circuit. I've just oiled the shaft, so it's probably going to be a little bit above 123, and we'll be recording the outputs and measurements as we go, and obviously I'm probably going to have to update those voltages for the generator. So the generator is switched from here, from over here at the bench. I've got a little power switch here that I can turn that off and on with. This turns off and on by hand, as does this, except the input of this is a little noisy. The generator is also a little noisy. So when it comes time to turning all that on, we'll just do so in short bursts, take a reading off the meters, and then I'll turn it all off and we'll go from there. So the first thing that I'd like to do is to power just this simple light globe from the rectifier, conventional rectifier, and we'll do a voltage and current reading at the same time. So we got voltmeter in series, the ohmmeter in parallel, stay. Volts, it's on volts. We can check the ohmage, 211. I've got 212 written up on the board, 210. Probably a little less because it's hooked to the load. It's measuring the capacitance of the condenser in the rectifier. So let's try that. Power up the transformer, and we have 131.3 volts and 0.06 amps. So up here, 132 volts and 0.06 amps. Okay, that's that power supply. The other power supply, this one here, is a little bit noisier. You'll have to read the measurements, read the meters, Connor. Pull it out, mate.
186.7 and 0.08.
Alright, 186.7 and 0.08, and I've got 187 and 0.08. Now we'll go to the generator, and this is going to get a bit noisier. .06, and how many volts?
129.5.
129.5, so it's gone up a little. It's spinning a little faster. 129.5. That's 212 ohms. Now, we'll go to the next resistance level. Place in the circuit a couple of these fans out of a microwave oven.
130.2 and 0.03.
130.2.
Mm-hmm.
130. I'll just say 130 because it's close enough. And 0.03.
Mm-hmm.
Did you see the light glow or not?
I'm not sure.
Yeah, you need to watch it. We'll do it again with the generator, just so we can see.
Sorry, 0.05. I must have got it after you turned the generator off.
Oh, 0.05 amps. Okay, that's better. Okay. So that's with the generator power. Now we'll go back to the rectifier. And first of all, my home-built transformer. Volts and amps.
196.5, and I didn't quite get the amps. 7 amps.
196.5 and 0.07. 196.5 and 0.07. Yeah?
Mm-hmm.
Cool. Okay, and then the other transformer, the other rectifier, which is a lot less noisy. How much?
135
Yep.
by 0.05.
Okay, 135 and 0.05. And we'll do a resistance reading. It's going to take a little time to settle. That'll do. Alright, so that's close enough. It's still dropping, but it's only dropping really slowly. So 0.765. So say it's 0.760. 0.760. Okay. 60k. 0.760. Alright, let's go to the next one up. And this time we'll do the resistance reading first. So this time we'll put 2 fans in series. And the resistance reading is what? 1.29. 1.293.
Mm-hmm.
And I've got 1.28. Let's make it 1.29. .293. Okay. First is the conventional rectifier,
Which is 137.5.
137.5. I've got 139.5.
And amperage is 0.04.
0.04. I've got 0.05. So 139, 137.5. 7.5 and 0.04, yeah?
Mm-hmm.
Okay, now we'll go to the other power supply, the noisy one.
Okay, it looks like it's holding it around 204.
204, I've got 201, yep, and the current.
Oh, sorry, 204.5. That's dropping again to 203.5, and the amperage is 0.06.
203.5. I've got 201. 203.5. 0.06. And it's because the resistance has changed a little, because it's now a little cooler. Even the air has come in, it's a little cooler, so the filament has to work a little harder to put light out there. Okay, now the generator. Meters.
128.5.
Yep.
And 0.04.
Yep. 128. So we've got a fluctuation of 1 or half a volt so far. Half a volt, plus or minus half a volt. And here we've got 132, 135, 137. And 180, 187, 196, 203. That's quite a big variation. You can see the trend already. An increase in resistance increases the load or the circuit voltage, decreases the current. Increase in resistance at the rectifier increases the voltage, decreases the current. Increasing with the generator, we get basically the same voltage. That fluctuation could hit a shaft, and a decreasing current. Let's see what the next one does. 1.6k. That's 3, 4, 5. I know what I put in. I put in this little resistive element out of a hair iron, and this is a variable resistor. So we'll go to this. From that into the variable resistor. This is an old variable resistor from the 30s. It was put into housing, into the very richest of houses, to dim the lights. And that ran. Yeah, here's the other side of the circuit. So voltmeter there. We'll do a resistance reading first. 2.664. 2.664. I got 2.651. 2.664. 664. 0.667. Now, generator.
There go.
Yep.
130 and 0.03.
130. And 0.03. Okay. So we're back up to 130. And I've missed that one there, haven't I? We haven't done 1.6k yet. We'll come back to that. Alright, rectifier. My circuit, my transformer. Feel it?
Yep.
Yep.
212.5.
Yep.
And 0.04.
212.5. 0.04.
Mm-hmm.
You sure?
I'm sure. It's changing between 5 and 4.
Yeah, leave it at 5. That'd be right. Because I might have nothing to put in there.
155 and 0.03.
155, 0.03, 155. And you can see the light globe. So you can see it a bit better. Okay. We'll find 160, 1.6, 4 fins. The difference is 400 ohms, which is, I think, just that one. Okay, so now we've got 1.6, haven't we?
Mm-hmm.
Right. Let's do the 1.6 readings with this rectifier. Oop, hang on. Gotta go to voltage. What's that say?
1.4. Sorry, 140.
Yep.
And 0.04.
Yep, good. That's what I got on the board. 1.6, 140, 0.04. And then my transponder, sorry. It's confusing because it's also my rectifier. Got it?
205.1 and 0.06.
205.1. 205.1. 0.06, did you say?
Yep.
So, same voltage. Increase is 300 ohms. 3, 4, 5, 3, yeah, about 300 ohms. And virtually the same current and voltage. Increases 300 ohms. 7, 8, 9, 10. 3.5, 2.5. Same current. Same. 5. Oh, we haven't done this voltage. Generator. Okay. Ready. On the meters now. Right, what were those readings?
130.
130 volts. Yep. Oh, hang on, wrong one. Yep.
And 0.04.
Yep. What have we got? 5.05. 5.05. Well, I suppose we'll put that in here. So
5.05, yeah.
5.05k. Five. Point 05k. It's going to give a reading here. First of all, generator. You have to give the teenage son as a...
Yeah.
Okay, what's it come up to?
130.
130. Do it again. How many amps?
0.02 and the light isn't lighting.
Yep, 0.02 amps, no light. That's what I got. 130 volts. Now, back to the rectifier. Yep. Oh yeah, there is light. What's the voltage?
219.5.
Yep. An average?
0.03.
219.5. .03, and we had light. Okay, so it's still increasing, and current is still diminishing. And then we go to the other rectifier. And voltage. What's the voltage?
151.
Yep. And average?
0.02.
0.02, and just a little bit of light on the filament. So 0.02 voltage again, sorry?
150 it's reading at the moment.
150.
Or 150.5.
151. Weird. Okay. 0.02 still?
Yep.
151 volts. .3. Okay. I don't know why the voltage has gone down. Let's go to the last reading, which is this coil in series as well. And I'll put it over here because it's easier. You just flick it to amperage, to ohmage. Now, what's that reading?
21.47.
21.47. I've got 21.06. 21.47. It's probably going to go down a bit. Is it slowly going down or not?
45 at the moment.
Alright, 21.45. That one. Yep, what's the reading?
163.8.
0.8. I've got 63.4 here. 163.7. Right, so I've got 63.4 here from now on. 63.7. So we're obviously over that little hump there of just about the right resistance. So we're getting up near the circuit losses to the zero current flow. The other transformer. What's that reading?
248.7.
200 and what?
48.7.
248.7. How many amps?
Fluctuating between nothing and 0.01.
0.01. 248, which is up again close to 260. 0.01 and no light. Now let's go to the generator. What was that?
130.
130 volts. Really? How many amps?
Nothing.
0 amps. On 30 volts. So, from that, voltage remains the same with increased resistance, amperage drops from 0.6 down to 0, or 0.06 down to 0. The higher voltage transformer with a 260 volt DC open circuit, the voltage rose with a decrease in resistance, and the same occurs with the rectifier from the lower voltage of 170 open circuit volts. The voltage is increasing with the drop in the current. Increasing resistance, current diminishes. Yep. Alright, so that's all I wanted to say about that, except for perhaps if someone could do this equation for me and explain why the maths doesn't follow the readings. Observation doesn't fit the plan. So anyway, that's all DC current. The next setup I'd like to do is something a little different.